All right, the question is, what is the pH of household bleach? Okay, and the first place that we're going to start with is we look on the container of bleach, and you'll find that it says it's 6.0% sodium hypochlorite. Okay, so if we just convert that to molarity, I've worked out that calculation in advance. It's just 6 grams per 100, that's what the percent means. 6 grams of the sodium hypochlorite per 100 grams of solution. We do need the density of the bleach, which I looked up online, and it's about 1.10 grams for that 6% solution per milliliter. And of course you could measure that if you had a balance handy. And then we convert the milliliters to liters. Of course there's our grams of solution, and then now we have liters of solution on the bottom. That's that part. And then we just convert the grams to moles by dividing by the molar mass of sodium hypochlorite. Okay, so in the end we have 0.887 molar sodium hypochlorite. Okay, so now what we're going to do is let's write an equation. Okay, sodium hypochlorite. Okay, the sodium ions we really don't care about because they're spectator ions. They're not going to participate in anything. So we can write this as hypochlorite, right? Just plain hypochlorite. And this is going to act as a base. Well, we'll see that in a second. Even if you didn't know, it's fine. We put that in water. And what's going to happen? Well, I think it's pretty clear. It can't give up a hydrogen, so it must take one. And we can write it like this. HClO plus OH minus. Okay, so this is our Kb, or our base equation. All right, and the question is, what is the value for this Kb? Because we need to know that. All right, so this goes back to what we were a previous video. We used the example of hypochlorous acid, okay, and we had its Ka, which was 3.5 times 10 to the negative 8th, right? So now we want to find the Kb, right? So what we can do is remember that the Ka times the Kb equals Kw. All right. So in other words, that 3.5 times 10 to the minus 8th times our Kb equals 1.0 times 10 to the minus 14th. That's our Kw. Good number to know. All right. So what we will do here is calculate our Kb based on that value. And so we'll have Kb equals Kw over Ka. If you just divide both sides by the Ka, you have 1.0 times 10 to the minus 14th divided by 3.5 times 10 to the minus 8th. And if you put that in the calculator, you get 2.86. So Kb equals 2.86 times 10 to the negative 7th. All right, that's the value that I get when I calculate that. Okay, and incidentally, you could also look this up in a table, and sure enough, in the book it shows it as 2.9, so that's good to two significant figures, which is really all that I have here anyway, but I include the third one just habit for minimizing rounding errors. But once we have our KB, we've got our equation. We know our initial molarity, which we calculated to be 0.887 molar. Okay, that's the initial. And we just set up our ice table like so. We don't care about the water. We don't have any of those to begin with. And so our change, again, we can't lose anything from 0, so we must be losing from this side, gaining on the 0 side. That's the shift of Le Chatelier's principle. You add some to the reactants, it's going to shift to the products to compensate. All right, so 0.887 minus x, and then x, and x, and now we put these values into our KB, much like we did before. This time, of course, we're going to find the hydroxide ion concentration and then find the pH based on that. Okay, so the KB symbolically is going to be the concentration of the hypochlorous acid times the hydroxide ion concentration. Those are the products divided by the reactants, which is just the hypochlorite ion. All right. So when we put this in here, we'll have x squared on the top for each of those, and then ClO will be 0.887 minus x. Okay, and that will be 2.86 times 10 to the minus 7th. All right, so now here again, we're going to assume, just like we did before, that the x will be negligible in comparison to this relatively large value. And I think that'll be safe based on this number here, but we'll test it just to verify. Okay, so based on that assumption, then x will be equal to 2.86 times 10 to the minus 7th times 0.887, and then we'll take the square root of that. Okay, so we put this in the calculator, and we get 5.0 times 10 to the minus 4. Okay, so considering that this is really only good to two significant figures, we should be just fine there. 0.0005 would make the slightest difference at the thousandth place, but really our significance is only in the hundredth place, so we're fine with that value there. Okay, so this is the concentration of the hypochlorous acid as well as the hydroxide ion. Of course, we're more interested in the hydroxide ion. And so what we're going to do is take the negative log of this to find the pOH, and what we end up with here is let me find this here. Okay, negative log of that answer, and we get 3.3 for our pOH. All right, so then to find the pH, we remember that the pH plus the pOH equals 14. Okay, so this will just be 14, or the pH will be 14 minus the pOH, and we'll get 11.7. Right? So this is the pH of the bleach that you have in your laundry room. All right, quite caustic, or rather quite alkaline there.